Hey guys, Mr. Corbin back with you again, along with Miss Powell. And this lesson is going to be on scientific notation. So, Miss Powell, have you ever had a really, really big number or a really, really small number and you just got sick of writing all the zeros?
Yes. So that's why scientific notation, which I ran out of room there.
Look, can you not just,
Okay.
can you guys even read that?
I'll squish it
No.
over. Notation.
No spatial concepts for Miss Powell right here.
Okay.
Okay. All right. So, Miss Powell, how does scientific notation help us write these really, really big numbers or really, really small numbers?
Well, sometimes a number can have like 5,000 digits.
Oh, yeah.
And this is going to be a shorter way of writing it. And where you'd use this would be the hint here in science.
Right.
You can either go out in space and the numbers be astronomically large, or you can go inside your body and it be microscopically small. So that's when you would use the scientific notation.
Right. And so, like what you'd be talking about would be the distance from Earth to Mars.
Right.
Or when you shrink down a picture the size to find the nucleus of a cell, something like that.
Right. So it starts off with a number, and this number is called the coefficient, which I don't really like calling it coefficient because we'll use that word later for the number being multiplied by a variable. But that front number, unfortunately, that's what they call it. Now, it's a strange rule that if you're going to be putting something in scientific notation, there's a rule that says there can be only one digit out here in front. So you can't put 25.7. Now you can put 2.57 because as long as you only have one digit. You also can't have a coefficient of 0.8193. You can put 8.193. So all of these coefficients has to have one digit in front of the decimal.
So there has to be one, what we would call real number to the left
Mhm.
of the decimal. And so you can have as many numbers after the decimal as you want,
Right.
but only one to the left
So
to
here
be in scientific notation.
I had one to the right, two to the right, three to the right. Doesn't matter how many on the right,
Sure.
like you said, just one to the left.
Now, when you talk about that next thing, and I'm like you, I don't like it that's called the coefficient, but
Mhm.
still you can remember it's a number in front of something that's multiplied. That something that comes after that is our power of 10, right?
Yes. And it's on 10 because that's what our number system is based on. So this 10 is
And-
now going to be called our base.
Right. And so what you mean by our number system, every time a decimal place moves one way or the other, it's a power of 10. If the number gets bigger, it's going to be a higher number of power of 10. If it gets smaller, it's a negative number of power of 10, right?
Right. Because you can go have $1, 10 times a dollar bill is $10. So that's why it moves over.
Right.
But if you have 10 times the number of $10 bills, you're at the hundreds place.
Right. And so we're going to show you this and give you several examples. So, Miss Powell, what have you got to start with?
Okay, so let's say you have a coefficient of 5.8 times base 10, but that little bitty number is called your exponent.
Right.
And this is what's important. You've got to look at how big that number is, 7, but you also have to tell whether it's a positive or negative. Now, if there's not a sign there, it's automatically positive.
Right. And so what that exponent number is going to do is that's going to tell me how many, and I call it jumps. I don't know what you call it in your class, but it tells me how many places to move the decimal place. And so this, if you think of the idea of multiplying times a number, that means your coefficient is going to get bigger when we actually turn it into what we're going to call standard form.
Right. So I put positive means big. So I'm going to start by writing the coefficient, 5.8.
Okay. And now when I multiply times that positive power of 10, that means that decimal place is going to move 7 times.
Right. And you can kind of think of it not like a number line. You have negatives get smaller. When you go to the right, things get bigger. So I always think of positive, it's going to make me go to the right. So I used to do bunny hops, but the kids got confused on the bunny hops. So I'm just going to put missing like
I
little
use bunny
blanks.
hops, Miss Powell. What?
Yeah.
You
but
don't
the
like my bunny hops? You don't
No,
like my bunny
because
hops?
sometimes the kids put digits here. Sometimes they put them in a
No, they
little
never do that in
shallow.
my class, Miss Powell.
Yeah, I don't like doing
Must be
that.
just your class.
So,
Okay, show us what you do in your class, Miss Powell.
okay, I take
We'll
the
do it
decimal.
different in my class. It's okay.
And if there's a digit there, it counts. So it's 1, 2, 3, 4, 5, 6, 7. And when I get to the seventh spot, that's where the decimal point gets moved. Now that means I can't leave it there, and a lot of students will leave it here and there, but a number can only have one decimal point. So that decimal point has moved from there to there, and every blank spot I have to put a 0.
I really like, Miss Powell, when you said that the first number counts as part of your 7. Again, that for me in my class, that would be our first jump. But like Miss Powell said, that 8 counts. It counts as one of your 7. So be real careful there.
Now, if you put commas at your jumps, this is the ones groups. This is the thousands group. This is the millions group. So this would be worth 58 million.
Okay. And so again, this is going from scientific notation to standard form. Standard form is like what you would see a number, just a regular number, okay? But scientific notation, that's kind of our shortcut number. Okay. Got another one for us, Miss Powell?
Yeah, so let's do another one where you got a positive exponent. So let's say it's 4.836, because remember you can have as many as you want to the right, but only
Okay.
one to the left, times 10 to the 8th.
Okay, so again, it doesn't matter how many numbers I have to the right of the decimal. When I go from scientific notation to standard form, I'm going to move my decimal 8 places.
And since it's positive, you're going to move them 8 places to the right.
And I like to tell my students, Miss Powell, like you said before, if it's a positive exponent, that means the number is going to get bigger. Okay, you have to go to the right for the number to get bigger. So let's say that was $4.83 would be 84 cents. If I'm multiplying times 10 to the 8th power, that means my number is getting bigger.
So I'm going to take the decimal where it is, and I'm going to make empty spots. 1, 2, 3, 4, 5, 6, 7, 8. Since I already had 3 digits there, I really only have to fill in 5 blank spots.
Because your decimal's got to jump 8 times.
Mm-hmm.
Okay.
So that means that decimal, it's nice on the board because I just take my finger and wipe it away. But if you're doing it on paper, you have to go back with the eraser. You've got to erase it and put it there, because the decimal point always goes at the end of a whole number. That's what this is called, is a standard number. Just like what you'd see if you were opening up your bank account, this would be how much money you'd have in it.
Well, that'd be a nice bank account, wouldn't it, Miss
So
Bell?
put your commas. So now, if this was your bank account, you would have $483,600,000.
Wow.
If that was your number.
If only teachers could make that.
Yes. Oh, I have that in my savings.
Yeah,
Okay.
probably Miss Powell.
Okay, so let's say that it changes to a negative exponent. So we're going to see what happens there. So let's say it's 7.84 times 10 to the negative 4.
Okay, so we're still in standard form.
Right.
Even though it changed to a negative exponent, we've still got one number to the left of the decimal in our coefficient. So this is standard form, and we're going to move it to,
Well, now
this is
scientific.
yes, but
notation.
we're moving it to standard
Moving
form.
it to standard form.
Thank you, Miss Powell.
So it'd be 7.84. Now, we've been playing the game of going this way, but if the exponent's negative, then negative means that we're going to have a very small number. And if it's small, then you have to go left.
Right.
So I'm going to take the decimal and jump 1,
Ooh,
2,
she said jump. Did you guys hear that?
3, 4. Now, that 7 counted as one of my jumps out
Right.
of 4. So I've got to add 3 zeros only. And this time, my decimal point is not at the end of my number, it's at the front. So I've got to remember to go back and take that off.
And again, look Ms. Powell said that if it's a negative exponent, see that right there? If the number is going to get smaller, so that means move to the left. The decimal moving to the left shrinks the number down. And so 4 places is what your decimal is going to move. And so it ends up being a really, really small number.
Now in class, sometimes we're doing problems on the board. We'll say it's 0.000784, but that's not the best way of saying it. You say it like a regular number, 784, and then you tell the place value of that last digit. So remember, this goes tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So this would be 784 millions. And that's how you do a problem like that. That makes sense?
I like that, Miss Powell.
Okay, so let's do
another negative one.
Now, if they give it to you in scientific notation, you only ever have to skip one digit if it's written correctly. So let's say it's 9.135 times 10 to the negative 2.
Okay, so the negative 2 tells me my number is going to get smaller. My decimal is going to move 2 places to the left.
So you go 1, 2.
And the 9 actually counts as one of my 2 numbers, right?
So you've got to add a 0 in
Right.
any spot you don't have. And this time your decimal points can go in the front. So you got to take that off.
And that looked great if it had some jumps in it, Miss Powell, the little
Yeah,
jumps.
but that's confusing for
The
the
jumps.
kids. So we're
Add
gonna
the
do
jumps
straight.
to it, Miss Powell.
And that's pretty much it. If
Yeah.
you're given scientific notation, you're either taking the decimal to the right if you have a positive exponent, or to the left if you have a negative exponent.
Okay, so that is going from scientific notation to standard form. We're going to come back here in a little bit, and we're going to show you the reverse of that, going from standard form to scientific notation. For Miss Powell, I'm Miss Corbin.
Miss Corbin, yes, you
Mr.
are, Miss
Corbin.
Corbin. Oh, yes, you look like Miss Corbin.
See, I had to bring her address a while ago. That's why I said that. Mr. Corbin, we'll see you back here in a little bit.